topic today is component design, finally faster, no more Excel sheets. Today we will show you how you can easily and fast building products directly in RFEM. My name is Andreas Hörold. I'm responsible for marketing and public relations. For instance, the German and English webinars, technical content of the website, newsletters, and so on. I will be the moderator today, and I will answer your questions during the webinar. I will be supported by my two colleagues. Yeah, they can introduce themselves.
Yeah, then I will continue. Hello, my name is Rebecca Goebel, and I work at Dlubal in product engineering for the new components add-on and the API, and I'm also working in the field of customer support. And today I will present the live demo for the components add-on.
Yeah, then also from my side, hello and welcome to this webinar. My name is Daniel Dlubal, and I am mainly responsible as Chief Operating Officer for the strategy and even for our HR marketing and sales departments. And for those who are wondering if my last name stands for the company, yes, it does. So I have something to do with our company. So with me, we are in the second generation of our owner family company, and this will be also for the future the same case. And then I say thank you to you, Andreas, for the introduction, and I would take over the presentation because I have here something nice to show you here in our webinar. All right, so when we are talking about, or maybe let's jump one step before. So for who is this webinar? So the webinar is especially for you who are modeling already in RFEM 6 and need to do design building products in addition to standard verifications. And next to that, of course, when you are dealing with Excel spreadsheets, with supplier or manufacturer software, so whenever you are transferring some internal forces done by the design, the structure analysis of RFEM 6, and you have now the internal forces, the results, and even some support directions, and you want to transfer and export those to your Excel sheets, to your spreadsheets, to other comparison tables, or even to third-party manufacturers, then this webinar is definitely for you. Another thing for which persons this webinar is also very suited is when you need to verify conditions in, let's say, complex structures that are not covered by any standard. Yeah, so you are out of the code and you want to have, let's say, this component-specific design, then this webinar is also very interesting for you. And especially when there are some manufacturers or suppliers and you are considering putting your products, your components, your series of components into a library of structure analysis, then this webinar is also for you. For everything, for everyone else, okay, could be interesting, but it is not really made for it. So when you're just dealing with the standard design of steel, concrete beams, and you don't do any, let's say, further component design of smaller things in the structure analysis, then this webinar is not for you. So now a question for you, because I want to get a better image of our visitors and participants of today's webinar. The question for you: how do you currently design building products like joist hangers, connectors, supports, fasteners in your structural design workflow? Please write it now into the chat. And this would be, for me, very important just to get a better understanding of which people we have here today. Okay, so take the time, invest this 1 minute, and please write your current design workflow into the chat. All right, first questions are appearing. Excel spreadsheets, Hilti Profis, okay. Also manufacturing, technical sheets, Excel, Word, okay. So we see third-party applications, web-based software, self-made Excel sheets. Okay, so a lot of Excel sheets, third-party software solutions, producer software, internal forces, exports towards Excel spreadsheets, compared to data sheets from, okay, so there are, let's say, different workflows, how to consider these kind of, let's say, building products, these kind of components. Thank you very much for your contribution for that. When doing structure analysis and structural design, then every structure consists of more than just members and surfaces. I think this is pretty clear. Yeah, so we do the slabs, we do the beams, we do the girders, everything fine. But a typical structure often contains dozens of building products in addition to the main structural components like beams, ceilings, slabs, walls. You have dowels, you have joist hangers, you have tension rod systems, you have some insulation elements, you have supports, you have bearings, elastomeric bearings, you have even steel joints. And then there's always this workflow gap. So you have the whole 3D analysis, calculating your internal forces, your stresses, your strains, your support reactions. Yeah, everything clear? But then when doing now with that, with these internal forces, now the design of these smaller products, of the building products like those joist hangers, then you always go mostly to another third-party application, to Excel and so on. And there's always a kind of workflow gap where you leave the interface, let's say the platform of RFEM, and go to another solution. Therefore, there are three approaches and basically one workflow problem. The one thing is that you go to the manufacturer software. I know that a lot of manufacturers and suppliers offer already some great tools. They're definitely great. And that you export the forces, the geometry, the support reactions to their tools and do the design. Everything fine. However, you have always this kind of, let's say, transferring issue that you have to update the forces or even the geometry when some updates are appearing in the main model. So you have always to transfer this information. So the input values must be transferred manually from RFEM. Then the second one, so like the PDF design tables. It's simple for quick design cases, but very inflexible and difficult to document in the structural report because it's always a kind of, let's say, sheet, and to put it in the global report, it's a little bit clumsy. And the third thing is that you have your own Excel tools. Yeah, of course, here you have the maximum flexibility, but also a specific risk, because what happens when some manufacturer updates their tools, their building products, and is your Excel tool also automatically updated? Yeah, and it's always depending on the creator of this Excel tool. So as soon as this creator is leaving, do you still know what he thought when creating this Excel tool? Do you know any specific detail about that? It's not always 100% sure. So there's always this risk. Another thing is, how much time do we lose when doing design with several applications and always transferring one result to another tool? And at Dlubal, we have a rough and even a very good estimation of our customers based on several surveys and feedbacks that 20 up to 30% of design time is estimated to be lost on pure data transfer. Yeah. And where do they occur? So transfer errors, especially when manually entering internal forces. There's always this gap. So I have done my 3D analysis, I have my moments, I have my shear forces, I have my support reactions. I put them to another tool, and then there can happen a lot of things, especially when your 3D model is updated. Yeah. So when you run the analysis from scratch again. Another thing is the loss of traceability in the review process. Yeah. Next thing is the maintenance effort with every model change, as I already told you. So especially when geometric changes are appearing, new stiffness values, new components. So this is always something which is a pain. Then another thing, the documentation effort for the report integration. So yeah, you have to put from different applications, the reports, put it into one global report. This is always very challenging. And then, of course, the knowledge dependency, especially on the creators of some third-party tools, Excel tools, and so on. Yeah, what I was when I working as a structural engineer in some engineering offices, we have also used a lot of Excel sheets, pretty fine and well, also simple to understand. But there was always, let's say, this dependency on that guy who was creating or who has created this Excel tool. And when he left the company or he was not there anymore, we could not ask him, okay, why did you do this and that thing? Yeah. So the thing is, if a standard changes, someone has to revise the code. So this is something you have always to be aware of it, and someone has to explain what the formula in cell actually does. So at the end, the question is not whether Excel works. Excel works brilliantly, yeah. But the main question is whether an engineering office should be still dependent on a single spreadsheet in 2026. And now here comes the solution. And this is something we always were thinking at Dlubal, how we can make your life easier as structural engineer, as someone who would like to develop his own user-defined design checks, and as manufacturer or supplier. And the expectations are very simple. First of all, place building products directly into the model and benefit from them. Secondly, transfer internal forces automatically into the design. Third, results in the same table logic as all other verifications. So when dealing with, in RFEM 6, directly with steel design, concrete design, timber design, and you know already the very transparent design formulas and so on, that you have the same feeling in the data table, so in the same table logic. The fourth thing, and also very important, is the consistent report from one tool, that you don't need to leave RFEM, yeah? That you can still rely on RFEM as one tool. And then as soon as changing are appearing, and now we come to point 5, the updating the model also updates the building product design. And now this gap is being closed for you because we have developed a new solution for you, the add-on components. Components is the right add-on as extension of your previous or already existing standard add-ons like steel design, like concrete and timber design, because now you can do here the design of building products, of components directly in RFEM 6. So components combines the design logic of the standard add-ons like steel, concrete. And when you would like to do your own design, your own user-defined checks, yeah, it gives you also the flexibility to do so with the help of the Dlubal API. So the building products are placed directly in the model, automatically supplied with internal forces, and verified using the same logic as all other structural components. So you can do the design of you get kind of a library in the Dlubal center of Dlubal. There are already some existing components. With these components, you can already do the component, or let's say the building product design. And when you want to do any user-defined design, yeah, like with your Excel sheets or like other third-party solutions, then you can use the Dlubal API to do your own things. To give you a better picture of where you can see this add-on in the main design workflow process, we start from scratch. First of all, with the modeling. I think this is clear. Second, low cases, loading, and then calculation. After that, we go to the design of the main members. So steel, timber, concrete, surfaces, I think pretty clear. And now there was always this gap, yeah. We switched to programs like Excel, to third-party solutions, did some, let's say, PDF comparison tables and so on. And now we fill this gap. We have now the add-on components, which completes this phase. because right now you can do the design of these building products like connectors, joist hangers, dowels, custom components, and use them to generate a structural report in one global program. And this gives you a lot of time back, saves you a lot of time, and also the flexibility to do really everything in one program, and also the certainty that you don't lose any data because of these transfer result exports. So there are 3 user groups we would like to attach. The one is the structural engineer. So the structural engineer who is just using the already made component and building products like joist hangers from the library. The second one is the engineer who creates custom components and maps in-house design logic. So who basically develops his own design with a Dlubal API. And third, the product manufacturer who would like to have his tools, his products into our libraries in order to offer his products to planners on one platform. All right, let's dive a little bit deeper into the first user group, the structural engineer. So there's a workflow we can separate in 4 steps. First of all, select the building product in the component library. So you select the product like the joist hanger. Then you assign it to one model object. It can be a member end, a node, surface. Then you run the calculation and the design runs automatically. And the last point is that you see the results in the main tables and in the report. The requirement for that is nothing, only the add-on. Yeah. And it is completely for free when having these add-on components. And you don't have to pay anything for those components which are already existent in the library. You benefit, you save time, it's consistent in your structural report, and faster updates when changes occur. And in addition, fewer transfer errors. The second user group is the engineer, so the guy who develops and programs his own design logic. Typical use cases, you would like to do custom design scripts for special connections. So of course, we will never ever offer all, let's say, component series. There will be always maybe something special, very special, what you need only for that case. Yeah. You can also convert your Excel standards into maintainable components. And the third thing is the plausibility checks beyond the standards, and even some workaround verifications for members without a dedicated add-on. The requirement of that is so that you need an API subscription, at least the basic API or higher. And your benefit is that you have the maximum flexibility. You're independent from third-party solutions, manufacturer software, and the design knowledge is, let's say, part of your company and documented in the office. The third thing is the product manufacturer. Yeah. So this is the third user group. And if you want to integrate us and implement us, your products, your solutions, your components, basically, then you can get in touch with us. So we would partner with you, and also looking for more partners. Right now, we are already working with some of them in order to implement these solutions, these products into the Dlubal library and the database. And as soon as they will be available for all people, that you can use them free of charge under the consideration that you have the add-on. So your benefit is that you have the technical product placement instead of conventional advertising. So you can use that Dlubal platform, that Dlubal library, and give the structural engineers the choice of using your product. So here, the summary. And now it would be also, again, interesting for me, which groups do we have today in this webinar? So please take now 30 seconds of your time and write it into the chat. If you belong to group 1, group 2, or group 3, You can even combine some groups that we get a better picture of our today's participants. All right, what do we have here? Let's take a look. So we have 1 and 2, so a combination. We have a manufacturer here, now a lot of structural engineers, now some engineers, so some development engineers, again, a combination of both. Okay, so quite interesting. Thank you for your contribution here. And now I have talked, I guess, enough. And now we go right into the demo. Yeah, so what you will see is that we work with a, let's say, timber stage with joist hangers. And then in this live demo of Rebecca, you will see step by step how we do some component series in the Dlubal Center, so how we do use them, which are already existent, how we do the assignment of these joist hangers and tension rod components for the member ends, how do we calculate it and how do we design it, and then also the creation and design of a custom component, so of a user-defined component. And therefore, I now forward the word to you, Rebecca, and go for it.
I'm very pleased to present the functionality of the new components add-on to you today. I have already prepared an AFO model for this purpose, which you can see here. The model contains 3 load cases. The first load case is self-weight, which also contains a pre-stress for the bracing members. The second load case is for imposed loads, and the last load case contains a wind load on the building. The AFO model is a small timber construction which has bracings in several fields. In the following, I would like to use the components add-on to model and design joist hangers at these 2 locations and also a pipe for tension rod for one of the bracing members. But before I start, I want to point out a small mistake that is in the model, and maybe you can already see that here a member hinge is missing. So all the other beams are connected with member hinges, but at this position the member hinge is missing, and I did this on purpose actually to show you a great functionality of the components add-on, which is the script after saving, which will manipulate the AFO model based on the component that is placed at this position. And yeah, I will get to this later, but please pay attention to this location in the model, and later you will see some change here. At first, I will open the base dialog in order to activate the components add-on. I go to add-ons and activate the components add-on, and this will add further functionalities to the main program. As the first component, I now want to create the joist hangers, and to do this I go to the navigator data and right-click on component series, and here I choose insert component series from Dlubal Center. By doing so, the Dlubal Center will open, and here you can see our component library, which contains several component series from different manufacturers, and you also have the possibility to filter this library by material or manufacturer or other filters. And for this example, I want to use joist hangers from the manufacturer Simpson Strong Tie of the type GBI. And after I selected one component series, you can see that there's a table at the bottom which contains all the components that are included in the series. So these are different components with different dimensions, but all of type GPI. And as the purlins in my model have dimensions of 120 times 240 millimeters, I'm choosing the first component of the series in order to match the dimensions of my purlins. And now I can close the dialog with OK, and the component series will be created in the main program of RFEM. And now we can see the component dialog with a visualization of the component. And in the components add-on, we have different object assignment types. For the joist hangers, the assignment type is member start or member end. And because of that, we have the possibility to change some settings for the alignment of the component at the member end. But for this example, it's sufficient to stay with the central alignment, so I won't do any changes here. Now I change to the parameters tab, and here you can see in the upper part, the user has the possibility to do some adjustments to the component series, for example, about the fasteners or about the partial safety factors, which can be adapted. And in the lower part, all parameters are listed, such as dimensions and load-bearing capacities that are needed. These parameters are mostly from the data sheet of the manufacturers, and they will be needed later for the design checks and for geometry reasons. Finally, I now have to assign the component to members or to member ends. And here I will choose the two locations I specified in the beginning. And you can still see the member hinge is missing here. And yeah, I confirm this with OK and also close this dialog with OK, and the components will be added to the RFEM model. And now you can see at this location, there's a new member hinge now. And this was done by the so-called script after saving, which is able to manipulate the model and to do certain changes when a component is inserted. These changes could involve creating a member hinge, like in this case, or changing the stiffnesses of member hinges, the stiffness of nodal supports, or changing the section of members. There are loads of possibilities, and it's a really cool function to work with. And you can also see the component has a great visualization in the model, and it also matches perfectly to the dimensions of my purlins, which looks really, really good. And now I'm going to add the second component series. So I go to component series again, right click here, and I insert the component series from Dlubal Center. And in the Dlubal Center, I choose Pfeiffer Umix tension rod. And in the table, you can see all the parameters attached to this component series again. And from all the components in the component series, I will choose an M14 tension rod, and by OK, I will add it to my model. And as you can see, the tension rod has a different assignment type, which is member. So this means it will be assigned to a whole member in RFEM, and therefore we don't need to do some adjustments for the alignment. And also here we have, of course, the parameters tab, which contains the needed parameters for the design checks. And I will again assign this component to the member. And for demonstration purposes, I will use this bracing member and assign it to the component. And here you can see this green triangle, which is in this case the visualization of the tension rod. So there are different possibilities. Like for the joist hangers, we have a visualization file in the background, which I will show you later, which is why the component is shown in detail in the model, but it's also possible to just use some default visualization and not specify a complex visualization model, which is the case for the tension rods. And now I would like to show you the component dialog in more detail and show you what it's made of. In the upper section, you can see the categories used for the structure and filtering of the components in the Dlubal Center. And below that is the heart of the components. This is because every component series in RFEM obtains its information from various files. First, there are the image files, which are responsible for the preview images, such as this one. Another important file is the Excel file. It contains all the key information about the components in a series and also often includes the data from the manufacturer's product datasheet. I will open this datasheet for you, and here you can see all the parameters attached to this component series, to the Pfeiffer tension rod, which is basically the content of the datasheet from the manufacturer. Another important file to define the component series is the parameter structure, which is a JSON file. And this file is responsible for the structure and information in the component dialog, which I showed you before. And this file looks like this. So here you can see the structure. The groups are the chapter names and titles of different sections of the parameter dialog. And this JSON file also connects the Excel sheet, which contains the values for each variable with the Python script, which is responsible for the design checks. And it brings everything together. And of course, there's also the script after saving, which I showed you for the joist hangers. So for the joist hangers, we have a script after saving, and this is responsible for manipulation of the model according to the components that are used. But it's an optional feature. It's not necessarily needed for every component series. And the most important file in the script is the script below, which is the script after calculation. This is a Python file, and it contains all the information regarding the verification process. It defines which verifications are to be performed, how they are to be carried out, and which values are used for them. It uses the syntax of the Dlubal API as well. I'm going to quickly show you how it's done. And yeah, here at the top we have one important function, which is define design checks, which specifies how the design checks are called and what should be included in the result table in RFEM. And yeah, later on we have a part where all the parameters are read and where the Excel data is connected to the parameters. And at the bottom we have another important function, evaluate single check, which is responsible for the design checks. And it reads the needed parameters from the JSON file, saves them in a variable, and in this line the design check for the tension design check is done, and the design ratio is returned to RFEM to be displayed in the result table. And now that both components are included in the model, I of course want to run the calculation. So I change the result table to components. And basically this result table is, the structure of this result table is similar to the result tables of the other add-ons in RFEM. And in the first section we have all the component series that are included in the model. In the second tab we can see the different components that are used in the model, because it's of course also possible to use several different components from one series. For example, if you have beams with different dimensions, then you could use different components for different locations in the model. And in this table you can activate or deactivate which components should be designed. Then we have the design situations tab, where we can activate or deactivate the design situations for which the calculation should be done. In this example, I'm only going to do the design checks for the ULS configuration. And in the last tab, we can of course also define objects to design and specify which objects should be used for the design checks. And now I can start to run the calculation. And by doing so, RFEM is creating the mesh and calculating all the load combinations in order to find the internal forces at the different locations of the components, to use them for the design checks of the components that were defined in the Python file. And now we can see the design checks were finished and were successful, and the results are filtered by the different assignment types. So in the first table we have the results for the assignment type member start, member end, which are the joist hangers in my model. And we can see 3 different design checks have been done, and here we see the design ratios of each design check. And if we switch to design ratios on members, we can also see the design check ratio of the tension rod design check. So now you already saw that it's pretty easy to model different components and add them to your existing model. You can also run custom design checks for different components from different manufacturers. And of course, it's also possible to document all the results and all the components in the printout report. I already prepared a small printout report in advance. And so this way you can create one printout report which includes all the model data, all the design checks from different add-ons like timber design and steel design, plus the design checks for all components from different manufacturers that you used. And I will jump directly to the components section. And of course, we also have the ability to include screenshots from the model and from the components. which is a really good visualization for the printout report. And of course, we also see which component series were used in the model, which manufacturers were used, which components from a series were used, what settings were made for the components, and of course all parameters that are stored in the components. And the most important thing, we also see all the design checks and the design check ratios in the printout report. So that you can use this one printout report for the whole design checks of your building and only have one document that's covering all. And now that you have seen how easy it is to integrate existing components from the Dlubal Center into your model and perform analysis on them, now I want to show you how to customize existing components and save them as your own components in the Dlubal Center. But to do so, it is important to note that a basic subscription to the API is required to use and calculate user-defined components. Additionally, an API key must be generated and imported into RFEM before use. And I'm going to show you how to create your API key in the extranet. So this is the landing page of my extranet account. And here I go to API and Cloud, API 2, and under My API Keys, you have the option to create a new API key, or you can use one of your existing API keys if you already have some. But if you don't have any, you can create a new API key, specify a name of the API key, and create a new API key. And if you save it, you will have access to this API key, which you can use in RFEM later. And now I will show you how to add this API key to your RFEM. To do so, I will open the console and switch to Python gRPC. And here you can see the small key button, which I will click. And here you can enter your API key that you just created in the extranet. So you have to specify the name of the API key and the long term of the API key value. And by clicking OK, the API key will be stored in RFEM and can be used in order to calculate user-defined components. And as this API key will be stored in a config.ini file, it is also important to allow RFEM access to this config.ini file, and to do so, it is currently necessary to start RFEM with administrator privileges. Okay, so these were the preconditions to use the user-defined components, and now I will show you how to create your own component series. So I will go into the component series dialog, and the easiest way to create your own component series is by copying an existing one. So I will copy the Pfeiffer UMIX component series. And now I want to, the component series I want to add is a rope from Fazer, from the manufacturer Fazer. And so I first specify a name. And now I will activate the user-defined checkbox. and you will see that all these input fields become active, and we can now choose which assignment type we have. We can choose a manufacturer. We can also add new manufacturers if the needed manufacturer is not yet in the database. We can specify a standard, but this is only for filtering and structuring of the component series in Dlubal Center. The important part is the part below, and here we now have access to the yellow folder icon, and we can change the files that are included in the component series. So I will first upload a new image file, which I already prepared. So you can already see the new preview image of our custom component. And next I will add the Excel file with the parameter data, which I already prepared as well. And I'm also going to show you the Excel sheet and also the data sheet of the manufacturer. So on the left, you can see the data sheet of the manufacturer. And on the right side, you can see my Excel sheet. And you can see the Excel sheet contains all the data from the data sheet of the manufacturer. And what's important is that every line of the file has a specific name in order for RFEM to know which components are included in one series, and the name of the columns is also important for the JSON file, which I will show you later. So now I will switch back to RFEM, and next we can modify the JSON file with the parameter structure. So I will open the existing parameter structure from Pfeiffer tension rod. And here I have now the option to adjust all the group names if I want to, in order to change the dialog with the parameters. And I also have to specify the keys which I get from my Excel sheet. So I can keep the group names for now. They are just fine. So I will only adjust this key, and the key always has to be the same as the column header in the Excel sheet. So in this case, my key is diameter, and also the spelling needs to be exactly the same as in the Excel sheet. The caption is custom, so it's just the caption that is displayed in the parameters dialog. The symbol can also stay SD. The unit is correct with millimeters, and the type is float, which is also right. I can also leave the group names of the second section. They are just fine, and this key I can also keep it, because for the Fatser ropes I also have the parameter FTRD, so I can just keep it as it is. But I will specify the caption a little bit better, so I will use design tensile resistance. The symbol, unit, and type can stay. For the next section, I will call this group rope characteristics. And the first key I want to specify is the fmin from my Excel sheet. And as a caption, I will use the description of this value, which is the minimum breaking strength. As symbol, I will use fmin. The unit is kilonewton again, and the type is float. And the last two rows are not needed, so I can delete them. The next parameter is FUK. This is the key. And as caption, I will use characteristic breaking strength. And the symbol is FUK. The unit is kilonewton again. The type can stay as float. And the last parameter I need to specify is A from the Excel sheet. You can see here. The caption for this is metal nominal cross section. The symbol is A, and the unit is square millimeters. Now I'm done with the JSON file, and I can just save this file and switch back to RFEM, and it will ask me if I want to apply these changes, which I will. So now we have the new JSON file included in this component series. As of the script after saving, I won't need it for this component series, so I will just deactivate this here. And also for the visualization file, as I said before, we don't necessarily need it, so I will also leave this empty here. But what is really important is the script after calculation. So I will open the existing script after calculation from the Pfeiffer tension rod, and as the design checks of both component series are quite similar, I only have to do a few adjustments. The first adjustment I will do is in the define design check function. There I will adjust the type and call it tension check, which is just a specification of the design check, which will be written in the result table in RFEM. I will leave the description and category as it is, and the subcategory as well. As I said before, we don't have to deal with the get group and get parameter functions for now. All we need to do is adjust this evaluate single check function. And here we can check this line. But as our parameter is also named FTRD, so the key we specified is FTRD as well, so we can leave this line as it is. But if you name your keys differently, you would have to do some adjustments in this part of the script. And another adjustment we need to do is here, because here we check which type of design check is done at the moment and which formula belongs to this design check. And in the top of the file, we said the type was tension check. So I also need to specify the same type down here. And in the next line, we see the design check formula, which is the same for the rope as for the tension rod. So I can leave it. And that's already it. So we already have the new script after calculation, which we can save. And we can apply this to RFEM. And now my custom component series is ready. And in order to use it again later and to have it displayed in my Dlubal Center, I will now save it to the Dlubal Center. And I can specify a custom name here. And now it's included in the Dlubal Center. I can leave this dialog by OK. We can see the component series has been adjusted, and now we have to add a new component as well that belongs to this component series. So I go into the components dialog, and here I will insert a component from Dlubal Center. And we can see here is our new component series that we just created. And at the bottom, we also see all the different articles in this component series that were part of the Excel sheet, and also the corresponding values. I will choose an OSS 14 for this example, and it's included in the components dialog now, and I only have to assign it to a member in my model. So I will choose this bracing member and assign my component to it. Again, we can see the green triangle, which specifies that we have a component here. And in the result table, I can now run the calculation again, but this time only for the new component series of the OSS rope. For the calculation, it's important to note that the API requests are counted for this analysis and deducted from your API credits. Now that the calculation has finished, we can see that our design check was successful and our custom component series could be analyzed. And we also see that the custom changes that we made to the script after calculation, for example, for the design check type, have been applied and are now visible in the result table. I hope I've given you a good first impression of our new add-on. Feel free to try it out, and we look forward to your feedback. And if you find that our library is missing components that you frequently use in practice, or if you are a manufacturer and would like to make your components visible to all of our users in the component library in the Dlubal Center, please feel free to contact us. We are delighted to extend our library. And with that, I'll hand it back to Daniel.
All right, Rebecca, thank you very much. Really appreciate this live demo. So for you as a summary, where does the add-on components save time for you? And it saves time from day one. So let's take a look how it was before. So in this case, as an example, we have 3 excellent programs. We have 3 manufacturer tools for joist hangers, tension rods, steel joints, RFEM for the main design. So what you have to do is Okay, you have to manually transfer the internal forces for an RFEM to another tool. Okay, then the next thing is you have 3 separate documents you have to put into the main report. And now this changes for you. So you save a lot of time because you can do everything in RFEM. So you can model the whole structure in RFEM. You can assign the joist hanger with a component, the tension rods, joint component. So basically every building product, every component, yeah. One advantage, one calculation run, all proofs, and you have also one report. And you neglect all these kind of external data transfers of results, support directions, and so on. So this is basically your main advantage and benefit. And what we are often asked. So now I go through with you the most asked questions. So some frequently asked questions. And let's start with the first one. Do I need an API subscription to use components? No, not for the included component series. So everything what we will deliver you as component series will be free of charge. And this library will be extended from time to time as soon as we implement more and more suppliers, so more and more products from suppliers and manufacturers. However, if you want to do your own user-defined design, you need an API subscription basic or higher. Next question. Which assignment types are supported? So right now, at launch, so we start the launch since yesterday, the members and member ends are available. What we have still in plan is the node surfaces and surface edges. Which building products are in the library? So right now, we are supporting members and member ends, and the library grows through collaboration with other suppliers and manufacturers. So we are already in touch with some manufacturers, and you will see that you can basically do some dowels, connectors, joist hangers. Does components replace my Excel tools immediately? Of course not. So not necessarily. The main advantage you get with components is that you have one platform. You can migrate your existing Excel tools or third-party tools and have a maintainable workflow. So it makes it by far easier to have everything in one platform and to not leave, let's say, the data, so the Dlubal platform. So it's very, very consistent and gives you a main advantage of, let's say, faster design. Some other questions. Is the components add-on the successor of RF limits? So for those who are longer in the Dlubal community and also used to use RFEM 5 or Step 8, you probably know that we had something like that and similar, and this add-on module was called RF limits. And when you are asking me, okay, is this the successor? Then you can see it as a kind of successor, but with a main difference that you can now really use it for user-defined verifications and not just only for, let's say, reaction or force comparisons. Second question, can this be used to calculate steel and timber joints? Yes, it will be possible. So the development is currently underway. And what we also will implement very soon is this DSTV connection. So in Germany, they're pretty known. Some standard steel connections where you just compare, let's say, the existing with, let's say, with the resisting forces, yeah. And this is something where you can do. So you can see this as a very fast design of, let's say, very standardized steel connections. Of course, it will not replace the add-on steel joints where you can really do any user-defined steel connections. Furthermore, with components, we will also support timber joints like these dowel-shaped fasteners. Can specific components of a certification be created? Yes. You can use these formulas. You can create these file packages and generate a component series of that. And are the results displayed in the main tables? Yes, also this is possible. The results, as you know it from other add-ons like steel, concrete, timber, these results are displayed in the standard output tables in RFEM 6, as Rebecca has already shown it to you. Good. So where you can see Dlubal components in the portfolio, you can see it always as an extension and as a connecting complement to the main design add-ons like steel, timber, and concrete. And as soon as you have to do with these kind of building products, don't waste time to do this in other applications. Use RFEM instead, because now you have with the components the possibility to do so. Now, just to give you a, let's say, an imagination, okay, of the investment you have to do, it's pretty fair, and let's say for the start also very convenient for you. So timber design 1850, steel design, concrete design 2950, and now with components we call a price which is just really 30 up to 50% cheaper than the standard design add-on. So you save a lot of money when using this add-on. And I have today a surprise for you. Before I go to the surprise, let me justify this price of 1450. Let's do a quick calculation. Imagine, and just assuming, you can save per project 3 hours of time by using this add-on. You have an hourly rate of 90 euros you put as invoicing, as charge. So basically, with just 4 projects, per year, this add-on is already pays for itself, even with a regular price of 1,450 euros. And now I make a special offer for you, just for today and the next 2 weeks. We have a launch price for you of really not only 1450, and what you get as price is, of course, the components add-on, the initial component library, which will be always maintained and extended, and all future component series extensions. And this not for 1550, so and this not for 1450, but for 950. So you save more than 35% doing the investment for today or within the next 2 weeks. So make a decision, make a good decision, and do the decision in investing in the add-on components, because you can save a lot of time, and what is more valuable than saving time in structural engineering jobs. This offer is not always possible. It's only valid until June the 3rd, 2026. So again, and now we are also posting the link to the web shop or to the product site, website. Do this, really do this and save your valuable time. I give you another 3 reasons to decide now. Take the early bird recommendation from us. Really do this. The price advantage of 500 euros in savings is a real value. Then secondly, you have the early adopter advantage. So right now you can already start with it. You can join, you can give us valuable feedback, and we take this into the consideration. And third thing is, you can already start your next structural analysis and already work on improving your internal structural design workflows. So 3 steps to the launch price. Of course, you can buy it through the web shop. You can get in touch with our sales guys. We configure, we activate the license with you. If you have any questions, get in touch with our people. And the next structural analysis you can already do with the add-on component. And if you are a manufacturer or a supplier, and if you are interested in an integration which gives you the opportunity to offer your products to our Dlubal data library, which is used by more than 130,000 of users. Get in touch with us. Please contact our sales team separately, and we will discuss the best implementation approach with you and find here a good solution. So again, take the advantage, make the decision right now to the investment of 950 of the add-on components and benefit from it. So what you take away from today? I'm pretty sure the expectation is clear. The gap is closed. The components add-on solves what Excel, manufacturer software, and PDF tables have bridged with difficulty so far. We have three target groups, three models. We have the structural engineers, the engineers who program and develop, and the manufacturer suppliers, and each with a clearly tailored application model. You have it directly in the model, and it's the most cost-effective solution. And at the end, you have this price advantage, 950 euros instead of 1450. Really, just a wallet for the next 2 weeks from today. So do this. All right. Now, this was the presentation of the add-on components. A good time saver, a good fit to the, let's say, a good fit to the Dlubal portfolio calculation. And now, Andreas, is there anything where we can support our participants from the chat? Are there any questions what we can now answer?
Yes, there were some questions, also good feedback to the presentation. One people from the attendees wrote, "This seems to be a game changer." Another question was, isn't it necessary to calculate the elements with the cross-section of the cable using a nonlinear method? Yes, you can determine the internal forces using a nonlinear method in RFEM and use the internal forces in the components add-on. It's a cable, nonlinearity, failure by compression, and so on. Then a question, how we can document the results. Rebecca showed the printout report where can be displayed the design ratio and so on. And you can download the finished model with the printout report on our website. In the next days, you will get an email with a link to the website with the recording and the model, and you will get the attendee certificate. That should be all from my side. You answered the most frequently asked questions before. I think we said, or we gave enough information. We can close the webinar. I would like to say thank you for the attention. Thanks to you both for the presentations. I wish all a nice rest of the day. I hope we can meet each other in a future webinar. Maybe you both would like to say something, Daniel and Rebecca.
Yeah, Rebecca.
Yeah, thank you for attending, and I'm really looking forward to your feedback and when you tried it out and
I can only agree to my speakers. I just want to say, enjoy structure analysis with the new add-on components. Do and make the decision of getting this add-on, and it will save time a lot. So enjoy it and all the best.
Thank you. Bye-bye.
Thank you. Goodbye.
goodbye.